Hello, everybody. We are going to get started in just a couple minutes here. We're going to give another probably two for people to filter in, get through all the lovely click download junk that you have to go to if you don't use GoToMeeting regularly. But we were just in the middle of talking about something. I was like, we should just go live because this is a fun conversation. So Keith, you were talking about long traverses, 300 meter traverses, 300-foot traverses.
Yeah, so what we're talking about is those intersections where we want to tighten the scans up as we go, so we don't wag the tail on the dog, so you don't start losing your scans. Because they're in the surveying world, you want to close your traverse. Well, sometimes you can't do that when you scan because you're just going straight down a road, then you're hanging a right and going down 500 more feet. So what we try to do is run a traverse and close it with the total station. But in about 300-foot intervals, we'll have an intersection where we put a lot of super spheres or smaller spheres that we can shoot with a prism, and we do use that to lock that section down as we go along. So we're actually tightening the scans up as we move along. So it's similar to what you were just talking about, but different.
Yeah. Well, yeah. I mean, the real advantage. There's no advantage in accuracy. The only real advantage, right, is your guys that are used to doing registration. Particularly if they do a lot of cloud to cloud, it just kind of slides right into their workflow, as opposed to them having to figure out how to deal with targets and prisms and pulling in control point files and all the other stuff. I mean,
if you don't have features, the job we're working on right now, if you don't have a lot of features, we got probably a 60-70-foot wall inside of a mill, and cloud to cloud just doesn't work well with that. So you have to use some artificial targets to be able to make that work.
Absolutely. We had a long conversation about that in our in our last Scan to BIM session, which was all about registration. Yeah. Which, if you haven't seen it, check it out on scantobimuniversity.com.
Nice plug.
It's the shirt. Yeah, but let's actually get rolling here on the real agenda for today. So let's kick off with a little bit of housekeeping here. Everybody other than our wonderful panelists is muted for the duration of the event. Sorry to take your voice away, but you do have the ability to ask questions, heckle, pick on people, make fun of Aaron for not having his shirt yet, though it's not his fault. That would definitely be FedEx's fault. Do that through the questions in the webinar. So in your little webinar panel over on on wherever it is on your screen that you put it, there's a little questions panel. Fill stuff out. We'll do our best to kind of pick those up on the fly. In the past we've been running long because we had so many questions. So what we've decided to do this time around is in the theme of Scan to BIM University, we will be having office hours tomorrow. So that's going to be tomorrow at 1 p.m. I believe Central. Paolo, am I correct? I'm gonna make sure my calendar is buried here. I believe it's 1 p.m. Central, 2 p.m. Eastern. All right, cool. And so that's gonna be a little 30-minute session. Everybody can come in, ask questions. We'll answer any questions we didn't get to answer this time around, but we're gonna be doing that separately. So yeah, but we will try and pick up some of those on the fly or at the end of this go round. We are recording it, so if you got to pop out early, if somebody else is interested in seeing it, don't worry, have them register. In about a week, we'll send out that recording. So just keep your eyes peeled. Anybody that registers before or after will get that link. So yeah, I think that's the housekeeping. So let's talk about our wonderful panelists. Aaron, tell us a little about yourself.
As I read down this, I'm like, I feel like I'm in a dating show. As a roboticist and seasoned entrepreneur, PhD from Carnegie Mellon University. Yeah, I've done those things. I've actually, when it gets to, I've got a few pictures to go with it. Roboticist, started a company a few years ago called Allpoint. We actually had some registration software. I think we're talking about registration, so some automatic registration, and then that company was acquired by Autodesk, so part of Reality Solutions ran Recap for several years. Left doing a new thing, so I'll talk about that. And then my fun fact is, right at the beginning of 2020, I thought it'd be a great idea with my family to invest in a bowling alley. That was a terrible, terrible timing.
Oh man, that's rough.
Yeah, but I don't know. Everybody, it's coming back. You're like, we're getting there.
I also liked seasoned entrepreneur, and I'm like, oh, if that means under pressure and temperature, he still tastes good. Right?
It's like not my first rodeo, but also I wouldn't call myself a veteran. Like you learn every time, and every time, like, why did I do this?
All right, Keith, please tell us a little bit about yourself.
Yeah, so like it says here, I'm the president of Piping Layout Consultants. That's our engineering design company. So we're a user of all these products, and executive with Infinity Design and Construction Group. So we have engineering design, and then we flip it over to our construction group, and then we actually go build the projects. Spoke in 2013 at the SPAR conference out in Colorado Springs on the CFD subject of producing a solid model from a point cloud to be able to do a CFD analysis. So I started PLC back in 2004 from scratch, and then also Infinity in 2013. Some fun facts: football coach, been doing that for about 7 years. CrossFit, volleyball, mountain biking, and then the reason I ride a mountain bike is because I tried to kill myself on a motocross bike. So too old for that now, though.
Yeah, I've got another friend that's that used to do motocross, and just the accident stories that I heard over the course of like 1 year. And I was like, oh my gosh, how do you do this?
That's why my back hurts now, but I wouldn't take it back. I'd do it all over again.
Oh goodness, yeah. All righty. And hi, I'm the host, Kelly. I work with ClearEdge 3D. We make actually automated solutions for doing scan to BIM. So this is pretty much my favorite of the 7-part webinar series, because some of my babies get talked about in this one. So yeah, but let's not dwell on me. Let's instead go have some fun talking about some actual software solutions. So as I was telling the guys, I had originally titled this in a very technical way, saying, pre-modeling solutions, because to me there's kind of this automated step you can do before modeling, before you get into kind of the manual interaction. But our CEO, who also was kind of our chief marketing guy, was not happy with my name. And decided to call it automated everything, the mythical easy button. So thank you, Chris, for making me now walk this back for the rest of the webinar. Because of course there is no easy button. Sorry, hate to spoil the fun. We'll get to that in a minute. But there are, however, lots of different things you can do before getting into your modeling that can make your modeling easier, more efficient, more effective. And those are the things that we really kind of want to talk about today. Keith is here. He's actually a customer of ClearEdge's. Keith uses Edgewise and has messed around a little with our Verity software. And Aaron's new company does some cool automated feature extraction stuff, and is also working on a really neat research project around meshing. Wanted to drag these two guys in to really kind of talk about this subject. And then to kind of get kicked off, I figured let's start with some meshing stuff. Aaron, you were mentioning this earlier on the call, just in terms of some of the upsides and downsides of meshing. You were mentioning some of the downsides. You want to do a quick run by of your thoughts on meshing, pros and cons?
Yeah, I mean, it's again, depending on the context, meshing is either going to work really well for you, it's going to be your worst nightmare. You got to keep in mind that you're applying a surface to points. It doesn't, magically replicate reality. So every time you see a fuzzy plane of points that represent could be a line or a plane, and you kind of like pick the best. It's kind of doing the same. Now, there's all sorts of techniques out there, all kinds of applications. Some of them do a really good job on, planar surfaces, but then, areas of transition, going from one plane to another, or more complicated geometries, it will interpret and it will create the mesh, and that's where you start to get into problems. It will create things that not necessarily are reality, but it's going to think it's doing the right job, and so it kind of falls back on you to go back and check it out. So for things like obviously visualization, for various types of measurements and simulations. There's a whole bunch of different categories and different applications for using mesh. But you just have to know where the failure points, and again, the things like noisy data, occlusions, gaps, where it has to fill in, create data where there's sparsity. It will do that. You may not be aware of it, and that might be a side effect or create an issue for you without you knowing it.
And you said one of the key themes that we will iterate upon, I think, in this call over and over again, is anytime you do one of these automated processing steps, the onus is on you to go back and check it, because computers aren't perfect and they make mistakes. They miss things, they make things that aren't real. Now, like this is a screenshot from a product called Point Fuse. It's a cool little product. They algorithmically get segmented meshes out of point cloud. So, in this case, you can see they've kind of highlighted some of these segments. They kind of break it up by what they see as surfaces. So, hey, that's also a surface. And you can go through and kind of grab these surfaces and say, oh gosh, these surfaces are an object. Those are heaters, and this thing is a wall, which is a lot easier than like manually trying to window all the points and break them out thing by thing, right? Like you're able to kind of pick surfaces and kind of quickly go through and do this kind of added intelligence work with segmented meshes. But yeah, it's kind of a fun, interesting way to process the data. Pros, though, on the one of the other big pros is just size. Typically, when we're dealing with point clouds and you talk like, oh, we've got a terabyte of point cloud data, that can probably be represented as 100 gigs of mesh data. If you've got 100 gigs of point cloud data, that's probably 10 gigs of mesh data. 10x reduction in file size is a pretty common number that you hear. So you lose some fidelity and accuracy, though, like you said, Aaron. Keith, do you guys do much with meshes? I think tank analysis was something that came up the other day, but
we've done it, done that with mesh to mesh comparison. We've also done cloud to cloud comparisons for deviation between wear points on equipment. To your point, we've actually scanned a mile from the Ohio River up to a melt shop and created a 10 surface, which is similar to things. You have occlusions in that, and you have it's going to fill it in. Real quick way to make a topo. Going through there and taking thousands of survey shots with the total station, especially when you throw the drone technology in across the open fields. If you're showing dirt, so obviously we had to clean the site and do stuff like that. But I actually scanned through the woods with a terrestrial scanner too. So it was an interesting project. But yeah, those are a couple of things we've used those for.
And they're really great as kind of an interim step for certain use cases, right? Or they may actually be a great deliverable. You know, like the tank analysis is the one that always comes to mind for me, right? People that want to get a tank, you know, a big petroleum tank or a, you know, chemical tank, and they want to kind of see if that's deforming as it gets filled, or if there's any fatigue issues. You know, having meshes that you can compare to each other. It's just a much lighter format than having you know, 10 billion points over and over and over again of the same thing. But yeah, and that meshing process is highly automated. One interesting note, mobile scan data meshes much better than terrestrial scan data because you don't have nearly as many occlusions or shadows. So if you're looking, you know, if accuracy is the name of the game, you're probably not going to be wanting to use a mobile scanner anyway. But if you know you're going to be going a mesh route and you don't need, you know, millimeter accuracy on stuff, mobile scanning is a great fit for that because you just get much better, more evenly distributed coverage typically. So random pro tip there. The other fun stuff that you can find a lot with meshing is classification. So the screenshots before were kind of manual classification, but there's some tools out there that will do automated classification. So this is actually, this is snagged from Pix4D's website. This has been around since 2017, apparently. I forgot how long it had been since they first released this feature. But basically the color of the points on the screen in that background image, they are algorithmically determining, you know, different surfaces, classifying them, and then you can basically treat it like layers, right? You can say, oh, I want to see the buildings, so I want to see the trees, I want to see the paving, and I want to see features, cars, things like that. And so this is all done highly automated. Now, again, you'll notice if you look closely at any of these images, you'll notice some mistakes. So again, you know, when you're dealing with automation, it's not perfect. It's not an easy button. It's I like to say it's an easier button, right? It should make your life easier, but it won't just make your life easy. Alas. Aaron, did you want to maybe show a little bit on your project, actually, the research stuff that you're doing? Here, let me make you presenter because I think that's some cool stuff. Oh, Steph, here you go. Aaron is now the presenter.
All right, yeah. All right, share screen. Can I pick which screen is showing?
Yeah, if you can hit share and change, and yeah.
Share, oh, change screen. Monitor 2, monitor 1. All right, can you see monitor 1 here?
Yes, we can.
Yeah, so real quick, you know, I gave the intro, currently working in All Vision, so we're kind of doing a mixture of things, some of which is that automated modeling, some of which is also context. So, you know, part of your model is 3D representation, but the other part of your model is like, what is this object, right? Is it a fire hydrant? Is it a facade? You know, those become important as you get more into your sort of more BIM and sort of life cycle management, asset management side of it. So we've been focused on that. But coming back, as I also mentioned, worked with Autodesk for a number of years. This was a project that we did with NASA, and you know, highlighted the need that, you know, once you get into, you know, full out documentation of an entire facility, you know, even the architectural elements can be very tedious, time consuming to create those. So always been kind of searching for that easy button. So this past year, we has started working with a combination of researchers and the National Science Foundation. The team we're called Deep Reality, and we are applying deep learning to the classification and creation of models from point clouds. It is, as we've been talking about, a hard problem. You may take one example and automate it very well, and it'll work perfectly on that one data set, but then you bring in another data set and it will fail catastrophically. And so learning is really the fundamental tools for allowing lots of examples to be more automated in terms of its creation. So yeah, the project we are doing scan to BIM. Again, a lot of the examples I think you'll hear later on are probably more advanced in what we're trying to tackle, but getting into those more architectural elements, that is what we're trying to do. We're culminating this all into an actual platform, and then here in a little bit, I'll give you email information for those who would be interested in participating in the platform, whether it would be from supplying data or trying out the system, or actually steering how we build it. We just to very quickly show, we've built a wireframe interface. So there's this notion of project where it'll be online. So you'll be able to submit applications. I'll actually kind of like skip through it. You'll provide a little information with your data, and then select its parameters, and then it will start that processing. Now again, it'll go through and automatically create things, but again, it won't be perfect. So from your experience, what we're doing is creating tools to allow interaction between the program and you as a user to inform it, to have not only correct but learn what it's again, you do hear a lot these days of machine learning and artificial intelligence. I won't get too deep into the woods, but as the process of automatic anything is a series of algorithms that does things like a segment. So what's different about the scan? It recognizes parts of the scan and recognizes material, looks at changes, and it looks at the relationship of objects to other objects. And so all these are processes that can be used, or learning can be applied to, so that you can now enable computers to do it faster, learn how to do it better than what we can. We're putting that framework beneath that interface that you saw that will then allow all of this to happen. And again, to create, again, work toward, not fully do, but work toward that notion of it, an easy button, and both creating sort of the 2D context as well as the 3D context. I think this is the final video. It's just showing kind of the various parts of the data as it goes through current state of the algorithm. But again, multi-year sort of program with NSF, and I'm so excited to be kind of developing this.
Yeah, this is something Aaron had asked me to participate in, gosh, late last year, and got excited about, and I was like, oh, this will be a perfect class to talk about it, because while this particular bit isn't productized yet, it's the kind of thing that anybody can participate in if they want to kind of pay into the eventual development of this kind of ML-based solution for automation. Because like at ClearEdge, our algorithms aren't ML-based. Our algorithms are human-coded algorithms that some very clever person came up with and figured out how to do, basically, and then taught the computer how to do it.
Right.
Whereas in this case, you've got a bunch of different people teaching a computer how to do it by example, rather than giving it instruction.
Actually, I killed can you share the screen real quick again? Killed, I was going to put up there's an email address here. for anybody's interested. Yeah, correct. Yeah, get this process again. Yeah, so this is the email address, aaron@allvision.io is mine, and the program is ai.scan.2.bim@gmail.com. Anyone interested, again, in participating with the group, helping us kind of work to create it, love to have you part of the team. Anyway, thank you.
Awesome. All right. Take that presenter back. There we go. All right. Yeah. So anyway, super fun project, and again, really focused on this kind of precursory step of, hey, let's train it. And at some point, it will be an also an easier button, but achieved kind of in a different way. But I want to dive in a little bit to kind of automated feature extraction as well. Though that was kind of a perfect segue, because this technology that you're working on, Aaron, uses meshing as an intermediate step, and then it gets to automated feature extraction. So it's this neat kind of phased process. Right. A lot of the tools out there, whether it's AllVision or whether it's Edgewise, these tools are kind of jumping straight from points to features a lot of times. So just to kind of give people an understanding of what this looks like in real life, you check a bunch of boxes, because that's how we've all been taught to model in 3D. And then you wait a couple hours and you get this. This is obviously not a complete model. And so this is the kind of thing that I mean when I say it's not an easy button. And we actually got a great question. What level of accuracy are we talking about? This is, by the way, from Todd. Thank you, Todd. You mentioned it's not perfect, meaning there's human intervention. Then Todd actually asked about ML. So you at least partially answered his question there, Aaron. But it's not the accuracy actually that suffers. So the interesting thing is, when you're algorithmically extracting from the point cloud, usually if it's not enough to get an accurate result, the algorithm just fails. So the kind of interesting thing is, like, when a person models, the thing you're worried about is accuracy. When the computer models, the thing you're worried about is fidelity, right? Because a person is really good at knowing whether this thing is a pipe or not a pipe. That's actually what the computer sucks at. The computer is really good at figuring out that it's a 3.5-inch pipe, right? Whereas the person's not that good at figuring that out, because they're not mathematically analyzing every single point to determine what is the average cylindrical, diameter of this, patch of points, right? They're kind of, this looks like it fits. So it's a different thing, and you can see here, gaps and holes and things not connected and pieces that are missing. There's handrails that are actually. Let me make you a presenter, Keith. You had this pulled up earlier. You had, I think you had it pulled up in Navisworks. So Keith can show you kind of a live model that's just the raw output. So yeah. So that we can hide the point cloud real quick.
Are you seeing this screen right here?
We are indeed.
Okay, good. So here goes the point cloud.
Poof. Yeah.
So you can see the handrail here, not connected. So you're picking up everything that is cylindrical in this extraction.
But this is, so like this is what I mean by it's fidelity. With a computer, you're worried about fidelity more than you are, like a dimensional accuracy kind of thing. These pipes are all going to be pretty stinking accurate. They're actually probably going to be too accurate. You're probably going to have to dumb them down a little bit. But gaps, because what's in that hole between the two pipes where the scanner didn't collect data, and then how do you tell a handrail from a pipe from a conduit? Those are the areas where the computers need human guidance, but it's a very different process, right? Than the kind of manual modeling process where the person can look, figure out the system really quickly, model it, and then they spend all their time trying to get the model accurate. You know, when you're computationally driving geometry, it's kind of the inverse, right? It's like you get all this accurate geometry, and then you have to figure out what the heck it is, and is it something you want to model? Did I sum that up reasonably well, Keith, or did I just?
Yeah. So a lot of times you'll have pipe that is not supported properly, so it'll sag in the middle. And Edgewise is auto extraction does a good job of piecing it together. You know, so if you go through there and draw it straight, it's not going to look right. So you can actually miter joint that if you wanted to show it properly. So you're right. Edgewise is going to pull it out really close. If I were to just extract it myself, I would just take one end, go to the other end, and boom, all the way down. And maybe that's okay with what I was trying to accomplish, but it won't be as accurate as what's coming off the point cloud.
Yeah. And that's kind of that balance of, you know, what is the level of accuracy you need? How do you get that efficiency that you're really looking to get out of that? And then there's other tools and stuff that people can use, well, either built in or, to kind of build on top of these things. Like in Edgewise, as an example, we can kind of automatically fill in the gaps, right? We have a different algorithm that does that, just, looking for, kind of parallels pipe segments. There's also some fun algorithms to go through and make pipes that sag just a little bit straight, but still let pipes that sag a lot be made out of multiple segments. So that kind of process of de-accurifying the model, right? So, or nominalizing the model. And that's, but these are all kind of unique things when you do this kind of pre-processing, pre-modeling step. Generally, you're getting stuff at a level of granularity and detail and accuracy out of that's maybe more than you actually need for your model. And then you're going to have gaps and holes and things that are missing. And so the kind of process of incorporating that into your workflow is different than just incorporating point clouds into a manual modeling workflow. But there's, I think I should take a second and just kind of describe a couple different types of extraction stuff for the audience. So there's a lot of different extraction tools out there. So there's tools like CloudWorks, there's tools like Asbuilt, there's tools like ours, there's tools like, there's all these different tools out there that will extract stuff from point clouds in a variety of different ways. Some of them do meshing, some of them, do solid object detection. Edgewise, which is the screenshot I've got right here. This is what I would call manual extraction, which is where you basically draw a box around something and tell the computer to figure out, what it was and how big it is. Oh, am I sharing my screen? Yes, all right, good. Then you have kind of semi-automated extraction tools, which are, Edgewise has one called pattern extract for structure. So structure, we can't automatically extract up front because there's too many shapes and the computer can't tell the difference between two back-to-back angles and a T. And a lot of times W sections, you only have 2 of the 6 surfaces that are scanned. So it's really, really, really hard, unlike pipes, to get all the pipes, automatically extracted. But structures repeat. So one of the things you can do is kind of like an intelligent array, right? Where it says, oh, well, now that I have a pattern, look for this pattern and copy it, but fit it every time. And then you have like the fully automated extraction stuff, like the piping tool. There's a couple other tools out there, InfoPoints. Trimble has in RealWorks, they have a piping extraction tool now that'll do some automated processing. But fundamentally, these steps all are going to generate, various levels of productivity. Manual extraction, you're still going object by object. The patterning and the automated stuff, you're getting tens, hundreds, or thousands of objects kind of overnight or over lunch, depending on how fast your computer is. Aaron, any thoughts? Did I miss manual?
No, I think those are the pretty good summary of the various types of modeling. I mean, I think next step though, you should probably talk about how they work in tandem together, because they always have to, right?
Yeah. No, and that's a perfect segue, because they do, and work in hand with just manual tracing, right? Because that's kind of the fourth easiest, most common form of modeling, right? It's just manually tracing over the point cloud. Yeah, and that's I want to kind of save the rest of the time to kind of talk about incorporating this stuff into workflows, but yeah, the point I wanted to throw out, to kind of wrap up this section is, it's not actually the easy button, right? And I'll do some dirty laundry, because this is kind of the fun. This is the thing you never see in our Clear Edge Edgewise marketing videos. This is called the smart sheet, because our marketing people know that spreadsheets aren't sexy. But when you use an automated extraction tool and you have 800 beams or 800 pipes and you need to QA them to make sure that the algorithm did a good job, and to get rid of the bogus, ends of concrete bags or handrails or stuff that, you need to get rid of, the fastest, easiest way to do that is using a spreadsheet, and kind of sorting by different parameters and metrics that we teach our customers how to do, and quickly dumping out pipes that don't meet certain criteria, things like that. But this is the ugly, dirty laundry of automated extraction, is all the stuff that you do afterwards to actually make that data, get it ready, get it complete, and get it, well, complete in air quotes, done, and get it ready to go to that next step, which is kind of your manual extraction, your manual tracing, all that other stuff.
I think that also, like, that picture though underscores just the challenge automation has, right? Like, you've got some what they call it, the mixed pixel because of the edge. You've got some occlusion, and it's trying to infer from that, just that bit of point cloud that represents the surface, what how this actually should be. So I mean, it's not an easy task from just speaking as one who builds automation.
Yeah, no, that is, this is the, everybody's like, oh, well, you have a 3D point cloud, why can't you just click a button and get all the structure? It's like, well, because this is what it looks like.
Be nice if it worked that way, right?
Yeah, like, you try and teach a computer that's a that's a whatever this is, 9x4 W section, from this steel standard. Yeah, I mean, yeah, anybody that thinks you're just going to load a point cloud and magically get everything done for you is they're decades away from that reality happening, if not infinitely away from that ever happening. It's a long time off, but all this automation stuff, what really is, it is good at, is making people a lot more productive, right? Yeah. And that's the goal. Like, you shouldn't go look for an automated tool to solve your problem and give you models. You should go look for an automated tool to take your staff that is currently spending 500 hours doing this task and drop that down to 250 hours, which you can then use to lower your fee and be more competitive, or you can use to make a higher profit margin, or or both. Mm-hmm. Right, but yeah, that's yes, the joys of the process, and actually, like, pull this up since we're kind of segueing there. this is an example of that. And then Keith, I've got a whole list of questions for you, but this is an example from a different one of our customers that was doing a big chemical plant, right? And this is something that this company does every day. Their job is to do scan to BIM on chemical plants, and it's not an easy button, but if you've got a chemical plant, you've got 1,600 scans, you've got tens of thousands, if not hundreds of thousands of pipe runs. That's where you can really see these big impacts from automation, right? Because then it's like, no, it didn't model all the piping for me, but it modeled 60 to 70% of it for me. I finished it up, and it took me 2,000 less man hours to do this than it took me to do my last job that was almost the same, right? And that's where you really want these automated tools to kind of come into play. Whether you're going the meshing route and you're using those meshes in your product, whether you need features, if you're doing something like infrastructure with, all vision, if you're doing more, vertical construction with something like an Edgewise, you're really looking for that productivity multiplier for your people. And that's where automation kind of comes in.
Yeah, this is all the way back in 2013. Quoted the job to extract everything 1 inch and above, including brackets and bolts and whatever. So being able to use Edgewise to pre-extract all the piping, so it's looking at specific pipe or steel, that cut my deliverable time half or more, because I was able to spend more time with the connection plates on a beam or what have you. So it was able to model a lot more on that CFD project than I would have been just manually extracting everything. So to your point, the other point I'd like to make is, you kind of have to have the end goal in mind. What do you want to get out of this? There's, like you said, Kelly, there's multiple softwares out there that extract from a point cloud. If it's just something you need quick, maybe you don't need to use software A. Maybe it's just you open up something to recap, throw it in AutoCAD, extract it, you're done. That's quick. If I'm going to do a whole plant, obviously I'm going to use Edgewise. That's going to get me to a whole lot closer to the finish line really fast than if I was going to try to start modeling all that. Then on the engineering side, pipe stress analysis, for example. Does the software allow you to PCF? That's a big deal, because most modeling softwares these days will accept a PCF file. But if you've got intelligent catalogs that go behind your modeling software, you could PCF in, apply a spec, dump it into a software similar to Caesar, and then you're doing your pipe stress analysis. When that task could take days, you could be doing your pipe stress analysis within 2 hours. So a lot of different things to consider when you're using your software and what your end goal is.
Yeah, and that's always the challenge with these things, is that it's like I feel like the easy path is relatively well handled by the kind of big everyday software tools, but when you run into these kind of specific needs around as-built modeling, well, none of the tools out there were designed. Like Revit's not an as-built modeling tool. It's not designed for that. That's not what it's for. It's a design tool. Same thing goes with Plant 3D. Same thing goes with PDMS. Same thing goes, and so it's this. That's where these specialized tools and specialized workflows come into play, right? Because, gosh, anybody that's tried modeling ductwork or piping from a point cloud in Revit, manually tracing them, you know what hell is. Like that is hell. It's just miserable. It's just awful. And so, that's where these kind of different things come in. And then, you know the end, because we talked about meshing. Revit doesn't take meshes.
Correct.
So in fact, we even have a question that came in that's like, try asking more or less how to get meshes. OBJ is a mesh format. How to get meshes into Revit. It's like, well, the answer is don't.
Put them in Navisworks. Put your Revit file in Navisworks.
Yep, exactly. You don't. Revit is not friendly with meshes. I mean, you can technically bring little meshes into the family editor and then load the family in and then have little meshes patched around your project. But, you know, connecting that, dealing with that, it's not a pleasant process. You know, Revit's a solid modeling tool. So you want to get to solid models. Yeah. Yeah. Begin with the end in mind. Always sage advice. But funny story, Keith. Actually, you had, I don't know if you even know this, but I think when I first met you, which was at SPAR in 2013, you literally gave me the pitch that I always give when I'm selling Edgewise, which is, why wouldn't you want to start out on the 50-yard line instead of your own 20? Because that was how you described it in a nutshell to me in 2013, back when I was back and wasn't even at Clear Edge, and now that is like still stuck with me to today. And so like seeing that you're a football coach, now this all makes so much more sense.
Yeah, you can explain anything in life with football.
There you go. Yeah, and also kind of a business question. You know, one of the things that I've observed is it's kind of tricky to get people excited about doing as-built modeling. And you had some interesting advice about this on our kind of warm-up call about hiring laser nerds.
Yeah, that was last week, wasn't it?
Yeah.
Yeah, so you have to be excited about this because believe it or not, in between the total station work, the field work with the scanner, the registration, the extraction, all the way down to if you're going to pipe stress analysis or you're going to tie into something that's going to be really accurate, all those steps have variables, and every time you introduce a human there, there's an opportunity to mess it up. And what I've found over the years is that people that get really excited about this stuff and get geeked out about it are the people that you want doing this, because every one of those steps, you know, you got to carry the accuracy all the way through. If you don't, and somebody else in the middle between a really good field crew comes in and registers and they don't really get it tight enough, and then now you've got a 3-inch bust on something on a $2 million machine. That's not going to work. So your crew has to be really excited about doing this. It is a lot of fun. It's tedious sometimes, but it is a lot of fun. But you got to have the right people to do it for sure.
Yeah, that back when I was running the virtual building group at Beck, that was always the trick. It was finding the right people that would, you know, if you're passionate about something, you usually do it right. If you're not, you usually do it wrong.
Yeah, you know, just simple surveying stuff, you know, occupy backsite, turn and check, right? A lot of people just set up, shoot something, and it looks good. Well, you could be totally backwards. So you think you're good, you're heading south when you should be going north. I've actually had somebody come back with data like that before. I'm like, did you turn and check? So we have it written on our data collector, occupy backsite, check. So it's just those little steps you got to do to make sure that you're in the same playing field. If not, you could get yourself totally backwards really fast.
Oh, definitely. And actually, Keith, why don't you, I'm going to share your screen, want you to share your screen again.
Sure.
Because I think the project we pulled up for just a second to kind of show the example, but I think just from a workflow standpoint, kind of understanding where all of this fits in, I think that's really useful bit of knowledge, because, you know, obviously you've got the scan, but, you know, nobody heard what this project was, what you were doing on it. And so just kind of maybe give us a window of how the kind of automated piece fits into the overall project delivery.
Sure. So this site, we've done quite a bit of work here before. Just below me here in this basement, there's a 36-inch pipe that we engineered, designed, and installed. I think like 3 or 4 engineering companies wouldn't even bid it because they had no idea how to get the answer. The answer was to scan it, obviously. This job right here, everything you see on the screen here to the right, every bit of that's coming out, and the new machinery and piping and platforms, catwalks, all that stuff has to be installed in a 20-day outage. along with that, we're not using the same foundations. So critical path, there's a few critical paths on this, but the really critical one is to be able to get the concrete poured so it can start curing out. So what I'm doing here is, although all this equipment's getting torn out, I've scanned it all, and then I've gone in and started plotting out all the existing foundations, because I want to see what I can tear out post shutdown and leave it there while I'm doing the new work. So the next step to this is going to start designing my new foundations in here for the new piping. Once I do that, I'm going to try to work around these so I don't have to tear them all out. The less work I have to do during that window, the better. This is also going to be a planning tool for us to remove and reinstall this. So we'll do some simulation as the machinery starts coming back together, along with the piping. Because you can put 100 people on this, right? No, there's no way, because it's these are small work areas all the way down the line. So there's a minimal amount of folks that you can put in these areas. So we have to plan that out as well. So we're going to use this as a planning tool. And as we're talking meshes just a moment ago, this is going to be this is something that burns you in construction quite a bit, is the levelness of the concrete. And I know ClearEdge has a floor leveling software, but you can see we've got quite a few different elevations down through here as we work through this. So I will be creating a mesh of this area just as reference. So you can see right here, this slopes down. The good thing about a point cloud is all the data is there and it's accurate. The bad thing about it is sometimes it's hard to see. If I put a mesh on that, I'll be able to see that very clear. So if I'm going to put a pipe support stand down here, it may work fine for me down on the south end of the project. Down here, it may be 7 inches of grout, which could be costly. Or I could have it the other direction where I've got all my supports built. They fit down here on this end. They won't even fit down there because they're hitting the concrete. Because most people just work in the perfect world of design saying, oh, that's all level. Well, it's not level. So yeah, we're going to be taking all this equipment out here, and then we're going to be redesigning the catwalks. 2 piping headers are going in here, 44-inch and a 28-inch. So this is going to look completely different. But that's why we took the time to scan this, and then didn't get a real good data on the steel that's there existing. But I will be using the extraction tool in Edgewise to extract that steel right below here. That's going to stay. And then I will be able to extract all these little tabs off of here all the way down through there. And then I'm going to start pre-laying out all my bolt holes. When they take short shutdowns, we're going to take one section of this out, lay out my bolt holes on the steel, put the old piece back in, and do this up into the shutdown. And then once we get into the shutdown, we're ready to put the new machine in because everything's already laid out. We'll be using this, there's all of our datum there. We've got survey targets. We got spheres. We actually have a specific type of prism that it measures the same distance from the end to the center as these spheres, real fast to set up and resect in off the total station. So if someone says, hey, I need you to lay out this foundation here, I can set up and resect in off of 2 points really fast because I've got them all throughout this work area from one end to the other. So I can set up anywhere down through there and shoot a point within 5 minutes. So it's just speed to the answer. One of the things I like to talk about with our construction group is put the tape measure down because we've got a total station. That thing is a lifesaver. We have a few of them actually. So yeah, that's just a little rundown. If you got any questions more about the job, feel free to ask.
Oh yeah, we got some interesting questions coming in. We have somebody that pointed out that meshes. So Mark McNulty pointed out that meshes can be imported into Revit for use to model in place. You can also bring them into the family editor, the real family editor. That being said, in-place families are generally considered extremely bad practice by any design firm working in Revit. They will kill you if you send them a model with hundreds of in-place families because it bloats the file size massively. And in general, mesh performance in Revit, if you have them in the family editor and you have hundreds of instances of mesh scattered through, you get some really undesirable behavior in Revit, just in terms of performance and stability. So possible, yes. Recommended, definitely not. Just because you can do something doesn't mean you should. But yeah, that is a great point. And for one-off things, if you've got a particular object here or there, or something with relatively little repetition, it is a great point. There are times to abuse tools when it's appropriate. Yeah, let's see here. Well, one thing that you said, actually, Keith, during all that I was like, that's a great point. Is just like, without laser scanning and without some of these extraction and automation tools, the way you would have to do this in the field would be, you'd have to rip stuff out first. You'd have to take field verification measurements. And there would be no way to get this job done in a 20-day shutdown, would there?
Absolutely not. Actually, the machine that we're going to be putting back in here, we're going to pre-assemble it in the road outside the wall there. And we're going to level it up. And it came from Spain, I think. It's 180 feet long. It's got about 180 connections on it. And they've tack welded all those together. So we're going to go ahead and just weld them out, all of them. And then we're going to plumb it up in the driveway. We're going to scan the whole thing. We're going to prefabricate both the headers, both the 44-inch and the 28-inch header, still be in the driveway outside. And we're going to take it out there and we're going to fit it up. We're going to make sure that piece fits. That's a job killer, to make 190 field welds in 20 days and try to get it fit up properly off of 2 headers. It's a big job. So we're going to try to eliminate as many man hours during the window. The only way to do that I know of is to laser scan the heck out of this thing, and then use the total station and the model to lay out everything you do. And that's another point that I don't think a lot of people catch on to, because people are not quick to change with modeling. Everybody likes to model, but then they still create 2D drawings and then they issue those for construction. Well, unfortunately, on this job, down on the other end of the job we're not associated with, they started changing the drawings, didn't update the model, and then somebody had a 7-inch bust on the caster. So the whole caster part of this project down there is 7 inches too far to the south. So it's important, if you're going to model and you're going to use total stations, those models will go in those data collectors. Keep the model up to date. That's your control document. If you want to produce drawings for reference, that's okay. We don't really produce them a whole lot anymore. Most of our data goes into the data collector, and then we're using that to do our layout with.
Yeah, and that's a great point. And then Aaron, you had brought this up earlier, and so I wanted to show this real quick. But obviously, all these automated tools, they don't get the job done. They just speed you up, right? And so it's like how this gets integrated with the rest of the downstream processes is a critical thing. And so, again, a lot of tools, either mesh or point cloud, there's variations of this, but one of the things that we do to try and make life a little bit easier is we also, just like we talked about segmented meshes in Edgewise, we segment the point cloud, right? So this is a point cloud that's been, after everything has been extracted through Edgewise, what we actually have here is, turn all the other ones off. So these are the point clouds that's just with the piece of ductwork in this particular room. So, we get the ductwork, we don't model maybe the VAV unit or something like that and the grill, but you can see what that is. So make it real easy to kind of pull all that stuff in. Same thing, like, oh, well, there's all the points with the pipes. Yeah. And so you can imagine, working with a piping consultant that's not familiar or comfortable with point clouds. You send them the entire point cloud. Yeah, they're going to be confused and not know where to start. You send them something like this, and they're just a lot better off.
Oh yeah, for sure.
So these kind of same thing. Here's all the structure, and then also really important is what's left. So this, I didn't load up the walls for some reason, but we also had walls in this model. But basically, this is all the stuff that didn't have geometry in Edgewise associated with it. So, in terms of what do I need to model to finish the job? Well, here it is. But there's not a bunch of stuff in there that I don't need to model, because it's extra stuff. But there's various different flavors of this stuff in all the applications, right? But it's not just about getting the geometry into the downstream application in a way that's useful. It's also about how to get the point cloud, because the point cloud is the most accurate reference, right? And so ability to pull in the remainder or the kind of segmented and associated points, it's a really useful tool to kind of help that downstream modeling that still needs to get done. And that is a great segue to next month's class, which will be all about just kind of traditional manual extraction and manual tracing and best practices. And do you model on the outer surface, the inner surface, the middle of the fuzz? You mentioned modeling off the fuzz earlier, right, Aaron? Kind of picking where to be. Yeah, where in the fuzz. So all of that, that's what we're going to be focused on next month in the next ScandiBIM University session. We got a couple of the questions answered, but we obviously have some we didn't get to. And again, we're changing things up. We're not going to run 30 minutes long this time. We're actually going to reconvene tomorrow at this time. So tomorrow at 2 Eastern, 1 Central, and I guess 11 Pacific, and having office hours. So Aaron and Keith may be able to attend, may not, but Sylvia and myself will be there to answer all of your deepest, darkest point cloud questions. They don't have to just be relative to this class. And anybody that did ask a question in this class, we will carry those questions over and answer them there, or follow up with you afterwards. One way or another, you'll get an answer to your question. And also check out the ScandiBIM University webpage or the ScandiBIM University LinkedIn group. We're about to start posting answers to questions from all the different webinars. Start getting those regularly posted in there. So lots of wrap-up stuff. But thank you, Keith. Thank you, Aaron. Thank you guys so much for your time today.
Pleasure.
And
glad to do it.
And thank you to our wonderful attendees for sticking around. And we will catch you all on the flip side or on the next one.
Sounds good.
Signing out.